All right, welcome back to the product rule again, because now we're going to do it with the chain rule. If you didn't watch the product rule video in the previous chapter, a couple of chapters ago, the one without the chain rule, I would highly recommend you check that out first, unless you're pretty solid on the basics. The chain rule does make them a lot more difficult, and students tend to get lost in them a lot more often. So what we're going to do is just sort of take a straightforward approach, really label stuff. You'll see how I do it. Anyway, we're going to try and get to the bottom of this stuff. As usual, I'd encourage you to work these by yourself. Like once you see the problem come up on each problem, pause it, see if you can work it yourself. And then if you can't do it, see how I do it. Just because this is really a category where you got to just work a lot yourself and get used to it, kind of get like muscle memory. The same way if you wanted to be a really good dart player or whatever sport you play, you know, it's got to practice a bunch so you don't have to think when you're doing it. Because when you're actually doing it, thinking is the enemy. If you're a soccer player, you don't want to be thinking about heading technique when you head the ball. You want to have headed the ball so much that you're not even thinking about that. All you're thinking about is where you want the ball to go. And same thing here. If you've done a bunch of these practice, they'll start to seem like old hat. And then when you're on the test and the teacher tries to throw a little bit of a curveball at you, you'll recognize like, oh, this is one of those chain rule product problems where they happen to throw in an exponential or something. You'll sort of like, oh, I've seen that before. Nice try, teacher. I'm going to get this one right. So that's where you want to be by the time you get to the test. The only way to get there is by practicing, and checking your answers in the back. All right, so the product rule with the chain rule is still exactly the same. The only thing that's going to change is when we're going to fill in the v prime and the u prime term, we're going to need the chain rule to get those. So let's take a look at why that would happen. For example, in this thing, now I'm always going to encourage you to label these. So I want you to label the two things that are multiplied together. Maybe we'll call that one u and call this one, oops, also u. Now call it v. So product rule is always just something multiplied by something else, right? And they're functions or whatever, but the point is, of the sort of mess of stuff we're taking the derivative of, it's going to be, you're going to need to pick part of it to be u, and the rest of it's got to be v. And then we're obviously going to need u and v, but also u prime and v prime. So let's just go through and write those out separately. This is sort of the key to not getting lost in the chain rule. So I've already got u and v, right? That's pretty simple. U is x squared, and v is 2x minus 6. But the things I'm going to need are v prime and u prime, and I don't have those yet. So real quick, off to the side, let's just say, hey, what does u prime equal? We're going to sort of figure it out separately, so we can just plug it in later. If my u is x squared, my u prime is just 2x. So that's pretty easy, right? And then my v was 2x minus 6, so my v prime is just 2. Because the derivative of 2x minus 6, the 6 goes bye-bye. Since it's a constant, all we're left with is the 2 out front. So now I've got my u prime and my v prime, and we can just go ahead and plug those in. Now this one turned out to not even be a chain rule, right? This is like your standard product rule. So f prime is just going to equal u, which is x squared, times v prime, which we already just figured out is 2, plus v, which is 2x minus 6, times u prime, which is 2x. All right, so easy peasy, not so bad, no chain rule involved, right? But you can see how using this technique of putting u prime and v prime off by themselves is going to help us out when it gets a little bit more complicated. All right, so next one, this is definitely a chain rule situation. So if I want to take the, well, this one's not so much, but this one right here is going to be a power rule because we have a bunch of junk raised to a power of 3. So when I calculate, call this u, I calculate this, call this v, my v prime is going to be a power rule. So there's definitely one where I'm going to want to write these separate. And just for kicks, I'll write them all separate here. So I'll write down u first, it's just x squared plus 1. So now I just take the derivative of that to get u prime, and that is a pretty basic one, it's just a polynomial, so the derivative is 2x. My v is going to be this whole thing including the power, so 3x cubed minus 3 to the third power. Now my v prime, this is going to be where we have to use the chain rule. So we're going to take the 3, move that out front as a new coefficient. Then u stays the same, whatever's raised to the power stays the same. And now our new power is going to be 1 less than that, so it's going to be 2. But now because it's the chain rule, I got to multiply by u prime, and that's the thing that's easy to forget. You'll have an easier time remembering if you're working it separate like I'm doing right here. So my u prime is going to be what? Well, let's see, this was my u. This is the thing being raised to the exponent, so that means my u prime is going to be the derivative of the stuff in the parentheses. that's going to be, the 3 is going to actually go bye-bye, so I'll just have 3 times 3, which is 9x squared. All right, so now I've got my 4 components, u, v, u prime, and v prime, each of the 4 things in this formula up at the top. So now let's just go ahead and plug in. So we get this whole thing is going to equal u, which is x squared plus 1. Then we got v prime, which is down here. Okay, so let's see, let's just simplify this. We got, well, we don't have to, but it's 3. We got a 3 here and a 9x squared here, so I'll just make that a total of 27 x squared times 3x cubed minus 3 squared. All right, so all that is just this first 2 terms. Ooh. So now I got to put a plus sign, and just to make it neater, I'll put the plus sign here. Now we need v, which is the original mess, 3x cubed minus 3 cubed. You know, I just got that from right here. Now I need my u prime, which is right here. I just calculated a minute ago, 2x. All right, so here is our answer. Now obviously, maybe there's something you could do with that algebraically, maybe you want to factor something out. If I was you, I'd pretty much leave it alone, unless you're pretty sure you have a teacher who's a total stickler for simplifying fully, whatever that means. Simplifying fully means different things to different people. But, you know, when in doubt, after you've plugged and chugged through this formula, leave it alone, unless there's something really obvious, like I combined this 3 and this 9x squared into 27x squared, just because it was so, you know, combine coefficients for sure. But as far as trying to factor out, you know, 3x cubed minus 3, because they both have that in them, it's like, oh man, that is too much trouble. Move on with your life. All right, so once again, we've got something times something, so let's just write it out separately. Let's call this u, call this v, just for kicks. So u is x to the 5th. Why is this a chain rule problem, by the way? I guess we'll find out in a second. And then v is going to be sine of 6x. Oh, that's why it's a chain rule problem. Derivative of sine is cosine of the same thing always. So that 6x will be true for both. But now we've got to multiply by u prime. And that's when the chain rule kicks in, is because there's a 6 right here, we've got to use the chain rule, and that'll give us a times 6. So this will just end up being 6 times the cosine of 6x, because that 6 is not part of the cosine. It's like this is a separate thing, and then times 6 at the end. So I'll just put that out front to make it simpler. All right, so now we've got our 4 components. Now we just plug and chug into the chain rule. You'll notice the same technique is going to work for the quotient rule, because that also has u's and v's and u primes and v primes. So all you do is just write those 4 things out separately and then plug them in. It'll cost you a little bit of space. You'll just waste a little bit of paper writing that stuff in the right side, but it's going to save you so much in missed points. All right, so once again, just plug in u. What was right here? X to the 5th times v prime. Well, that was the messy one. So 6 cosine 6x. And then we're going to add v, which is sine 6x, and u prime, 5x to the 4th. All right, this one I think would look a little bit better if we just recopied it and rearranged. You know, this 6, it would look better if it was right there. So 6x to the 5th, cosine of 6x, and that 5x to the 4th, I would prefer to be out front. So it's totally obvious that it's not part of the sign, you know. I want it to be really obvious that I'm just taking the sine of 6x, not the sine of 6x times 5x to the 4th. So that's why you usually put stuff like this out in front of the trig function, so it's obvious that you're not taking the sine or cosine of that particular chunk of junk. All right, good stuff. Another one. Okay, now this is going to be a double chain rule, because we're going to need the chain rule to find both the derivative of this and the derivative of this. So let's take a look. What's my u? E to the 1 minus 2x cubed. U prime right below it. All right, how do we find the derivative of an exponential? Well, it's just going to be that same exponential times u prime. So it's still going to be e to the 1 minus 2x cubed. So it's its own derivative basically. But then the chain rule makes us do that times u prime. And u prime is just the derivative of the exponent of e. A lot of times students, the confusion they'll have about these derivatives of e's is that they won't be sure what their u is. but the derivative formula for exponentials is the derivative of e to the u equals e to the u times u prime. So the point here is that the u is just the exponent, not the whole thing e to the whatever. So that means when I do my times u prime here, and I'm going to write it out front just because I like it that way, but when I put the u prime here, it's just going to be the derivative of the 1 minus 2x cubed, which is, take the derivative of 1 minus 2x cubed. The 1 goes away because it's a constant, and we'll just have the derivative of negative 2x cubed, which will be negative 6x squared. So I just put the u prime out front because whenever I have an e to the anything, it just seems like that's another one of those things that, just like trig functions, where you'd prefer to have any coefficients or random variables like x out in front of it. All right, so v, real easy. We just grab it right from the problem over here. So that's just ln of 4x. And let me think real quick. You might not have taken a derivative of natural log, but I did cover this in the chain rules chapter, taking the derivatives of natural logs. It's just 1 over 4x. So this is the derivative formula for ln is just d over dx of ln of u is just 1 over u times u prime. So the derivative of natural log of 4x is just 1 over 4x. Just take whatever's here and put it downstairs under a 1, and then times u prime. U is just whatever is behind the natural log. So in this case, it's just going to be 4. So that'll be 4 over 4x, or just 1 over x. All right, that also happens a lot. So now we got our u prime and our v prime and stuff, so we'll just plug and chug. My u is e to the whatever, so e to the 1 minus 2x cubed. My v prime is what I just found, which is 1 over x. I do a plus sign, and my v is ln of 4x. Kind of made a mess out of it when I was explaining that derivative. And then u prime is just, that's the nasty one. So negative 6x squared. Now I'm going to put all this stuff in parentheses just because when I multiply by all this junk, I want it to be real obvious it's multiplication. So negative 6x squared e to the 1 minus 2x cubed. All right, so now I have a big mess here. Again, you could just turn it in at this point. I'm just going to rearrange things a little bit. That 1 over x doesn't look that good to me. I'd rather put the e to the 1 minus 2x cubed. And then if you multiply by 1 over x, that's the same as just putting an x downstairs. And then I'd like this negative 6x squared to sort of be in front of everything. So it's pretty obviously not getting the natural log of it taken or anything. So I guess I could have done a minus here. So minus 6x squared, since we have a negative in front of the 6x squared term. Then we got an ln of 4x. And then we got, maybe I'll put a dot just to make sure that's really obvious that it's not the ln of e or anything. It's just e1 minus 2x cubed. All right, so see how messy these things get. If you just tried to go straight from the original problem to writing down your answer, it's a little sketchy. Once you get solid at these, like I would probably do that if I was doing it myself, and I want to get through it fast, I would probably do that. If I was taking a test, I would be really careful. But again, that's something with practice. You'll get faster at these, and you'll know what kind of mistakes you make. So you'll get better at figuring out a way to do it fast and accurately. But for starters, definitely do your u's and your u primes and v primes and stuff off to the side, because it's just a better way to make fewer mistakes. All right, so once again, we just label them u and v. You can see this one's kind of nasty because we have a square root and a big polynomial. But if you're listing out everything separately, like I've extolled you to do, then it's no big deal. So u is just 3x squared plus 6x plus 4. That means u prime is just going to be the derivative of all that, which is 6x plus 6. V, we just get straight out of the problem. Now I am going to write this, I'm going to write this as a power, because the key to taking the square roots of the derivatives of root expressions is to turn it into an exponent. So we're going to write that as parentheses 2x cubed minus 9 to the 1/2 power, which means that when we find v prime, it'll be just a simple power rule. Take the 1/2 old power times 2x cubed minus 9 to the negative 1/2. And now we've got to multiply that by the derivative of what's inside, what's inside the power rule, the base, which is derivative of 2x cubed is 6x. All right, hopefully that didn't run off the page for you. All right, so now we're ready to just plug and chug through the formula. U is, wow, a lot of stuff. Plus 4. Then we need our v prime. That was this mess. So that 1/2 and that 6 right here, that 1/2 and that 6 are going to cancel to 3. And I'll put the x, and then we'll have the 2x cubed minus 9 to the negative 1/2 power. All right, so that's just this first two terms. You can see how ugly that would have gotten if we weren't working it separately. All right, so then we need our v, which is 2x cubed minus 9 to the 1/2 power, and finally u prime, which is 6x plus 6. All right, good times. Now, if you're really felt like munching on this thing for a while, you could say to yourself, you know what? This 2x cubed minus 9 to the negative 1/2 power, really that's, first of all, it's a square root, and it's in the denominator. So you could rewrite this with 2x cubed minus 9 as a radical in the denominator of a giant fraction under all this other junk. And then you could, you could take this 3x and distribute it into this polynomial to have less parentheses. And you could do something similar on the other one. But I would just walk away at this point. You're going to get almost all, if not all your points at this point. And the chances of executing all that other stuff without making any mistakes sort of outweighs the time you'd have to invest in it on a test. All right, so why is this one crazy? I could take a guess just looking at it, but let's see what happens. Looks like the really crazy thing is we're going to have a power rule on the sign of some stuff. So we might have some nested chain rule action going on here for that second thing. But hey, let's just get to it. Call this U. Call this V. I'm suspicious these could be long, so I'm going to, instead of putting it off to the right like I usually do, I'll put it right here. Give myself the maximum amount of room. So U equals e to the 5x minus 3. No problem so far. U prime is just going to be that same exponential, but times U prime. So it's the derivative of the exponent, which in this case is just going to be 5. Because the derivative of 5x is 5, and the derivative of negative 3 is nothing. All right, so what is our v? This is going to be the ugly one. V is the sine to the 6th power of pi, pi minus 2x. All right, doesn't look so bad, but now v prime is what's going to be wild. So ultimately, this is a power rule. And if you're not sure how to take the derivative of this, you can watch this. But also, in the chain rule chapter, I covered, there's a whole video about taking the derivative of trig functions with the chain rule, because what's really going on is this 6 power right here, the exponent of 6, that actually applies that whole sine of pi minus 2x. Just because of the, for confusion reasons, or for clarity reasons, I should say mathematicians put the exponent of the sine kind of right there on the shoulder between the sine and what's the sine of. But really this is like an exponent of 6 around the whole thing. So that's why it's a power rule to begin with. So the derivative of anything to the 6th power is going to be the old exponent, which is 6, times whatever the powers of. So same base or the same u. So that's going to, so sine of pi minus 2x. All right, and all that's to a new exponent, which is 1 less, which would be 5. But then we got to multiply by the derivative of what's inside the power, right? We got to multiply by the derivative of all this stuff. But that's going to be its own little chain rule. The derivative of sine is cosine of the same stuff. But when we take the derivative of sine of some stuff, we got to it's cosine of stuff, but also times the derivative of whatever the stuff is. So we got to take the derivative of that pi minus 2x, which is negative 2. All right, make sure I got the right number of parentheses on that. So that was the mess that is v prime. I guess we could rearrange this a little bit because we have a negative 2 off to the right. Combine that with this, the 6, and we get negative 12. And then we got the, everything else is pretty much the same. I'll move the 5 exponent to the usual place, so put it right there. Pi minus 2x. And then we got cosine of pi minus 2x as well. All right, so that is our v prime. Pretty crazy. But now that we know all that stuff, we can just plug into the formula, which is u v prime plus v u prime. All right, so u first, haha, it's going to be e to the 5x minus 3. V prime is that big mess I just got, negative 12 sine to the fifth of pi minus 2x times the cosine of pi minus 2x. Wacky. All right, so plus v. This is not all going to even fit on one line. That's crazy. Yeah, I'll just throw in a plus sign. Go to the next line. You know, whenever I work with students, and I do this myself sometimes, you try and like sort of cram this much stuff into this much space before you get to the edge of the page. It looks horrible, and worse, that's when you make mistakes. Because when you're jamming your writing down, and it's not your final answer, it's just one line in a long problem, it's like most of the mistakes students usually make are in that little tiny scrunched up space. Because you just can't see what's going on. Even if you think you can tell what's there, you can't tell. All right, so we got v, which is sine to the sixth of pi minus 2x times u prime, which thankfully it was easy, just 5 e to the 5x minus 3. All right, so at that point we've taken the derivative. I won't bore you with reorganizing this, but as I've said before, there's not much I would do this one. You know, maybe you could move this 5 out front of this term just to make it look a little bit better, but that's pretty small potatoes. All right, so that was it. Tricky example. Why is this one tricky? Because it seems like the one we just did is way gnarlier than this one, right? Well, it turns out the subtlety here is we're going to have to be really careful with the fact that we have a 5x and a 4x. That's just kind of tangent, you know, secant of 5x, tangent of 4x, apples and oranges. We can't combine them, can't do anything. It's just two totally separate beasts. So we're going to call this u, call this v. That means we'll just have to be really careful to always write down either 5x or 4x after each function, of which I'm sure there will be many. All right, so u is just secant 5x, and we'll have to use chain rule in each one of these. U prime, derivative of secant is secant tangent, so secant of the same thing, the 5x, tangent of 5x, but then we got to multiply by u prime, and our u is this 5x, so that means our u is just 5. V is tan of 4x. V prime is the derivative of tangent, which is secant squared of the same thing, so 4x also. But then we got to multiply because of the chain rule by u prime, and u is a 4x, so that means we have a 4 right here. All right, so that doesn't seem so bad so far. Let's see what happens, see if we don't get anything mixed up. All right, so first, let's see, the product rule is u v prime plus v u prime. So u is secant of 5x. Then we need a v prime, so that's 4 secant squared 4x. Then we need a plus v, so tan 4x, times the u prime, which is 5 secant 5x tan 5x. All right, so again, it doesn't look as bad as it could have. I would rewrite it, just this 4 sitting in the middle right here doesn't look good to me, and that 5 doesn't look good. It'd be too easy to confuse those with the 4x and multiply them in. So I would rewrite this one as 4 secant 5x secant squared 4x plus 5. And we can't combine any of this, right? Because we have a tan 4x, tan 5x, secant 5x. None of that stuff can be mixed and matched, really. So we got 5 tan 4x secant 5x tan 5x. All right. Excellent. Hopefully I didn't make any mistakes on that one. But as you can see, the chain rule is not the end of the world as far as the product rule goes. You just want to be real careful. Do your u's, u primes, v's, and v primes totally separately. Keep them on their own. Keep them, you know, your work off to the side. That way when you plug and chug through the product rule, it's no big deal. All right, so stick around for the quotient rule. Same thing's going to go down, so hey, you practically don't even need it at this point, right? But, you know, the quotient rule is a little bit tasty, so check that out.